Peace, mercy, and blessings of God be upon you, dear friends. Again, in a new lesson, which is the control circuit for the operation of a three-phase motor that works in two different rotational directions. In the previous lecture, we understood how the idea of rotating left and right came, and the idea of reversing the motor's movement. Now we want to apply this circuit as if you are in a practical laboratory with an electrical panel in front of you and you want to connect the important components and parts in it. And as you know that the circuit here is divided into two parts, a circuit for power, which is connected in the end of the load, which transmits the electrical current to the load. And the second circuit is the control circuit that controls the entry of the feed or the separation of the feed from the load. Now in this lesson we will learn how to connect, how to operate and check circuit. Stay tuned. We have the external network with the neutral line, and as you can see the lines of the main cable inside the factory or facility, and all the total load current will flow in it. A point of the line R, a point of the line S, and the point of the line T are connected to the main circuit breaker. As usual, as we explained to you earlier in the first lesson, the same idea of connecting a control circuit to operate a three-phase motor was given. But there is a new addition to this lesson. The three phases enter the main circuit breaker and then into the overload. As we have always explained in short, we choose the main circuit breaker so that the rated current has twice the main current of the motor, so that the main circuit breaker will live for a longer period of time as a result of the effect of the continuous operation of the current and its temperature in it for 24 hours. For example, if we assume that the contactor works throughout the day, in the same way we choose the value of the contactor, a three-phase 32 ampere if the motor load is 16 amperes, and it works on the three-phase system. The overload is the part responsible for protecting the electric motor or the load. If we set the value of the overload to 16 amperes, this device must disconnect the power circuit if the electric current rises above this value, even if the value increase is 16.1 ampere. It's a protection for the motor from damage and burning of the internal coils in it as a result of the high heat. Now there will be two contactors in this circuit. First contactor with a start switch, and the second contactor with a start switch also. We will take a point from the line R to the first point of the contactor. We will take a point of the line S to the second point of the contactor. And we will take a point from the line T to the third point of the contactor. And then we output the lines in the opposite directions. As you can see, the red line R enters the contactors and exits to the line S line in yellow. The S line in yellow enters the contactor and exits to the R line in red. The blue T line remains the same. With this movement, I flip the faces on the second contactor and left the arrangement of the faces as it on the first contactor. In other words, the faces on the first contactor are arranged in the order RST, while the faces on the second contactors are inverses of SRT. In this way, if the first contactor works, the motor will rotate in a normal way to the right. And if the second contactor works, the motor will rotate in the opposite way to the left. We complete the connection from the outside, the overload to the electric motor. Thus, the power circuit is ready and connected. Let's now see how the control circuit is connected. I mean, how we give the commands to the control to start the first motor and turn off, then start the second motor and turn it off. This is done by controlling the operation of the two contactors. We have a push button on for the motor rotation movement to the right, and we have a push button on to move the motor to the left. Push buttons on are always normally opened. It has open internal contacts. Here I will use the opened auxiliary contacts. Here I will use the opened auxiliary contacts for the contactors 13 and 14. In addition to the closed auxiliary contacts 21 and 22. K1 stands for the first contactor and K2 stands for the second contactor. Now I want to add the stop push button because I need at any moment turn off the motor. The stop button is always normally closed, meaning that the internal contacts are always closed. In overloads, the contacts here between 19.6 and 95 are always in the closed state, meaning there is a connection between them. I want to start connecting the control circuit. First thing, we get to the main circuit breaker. And then pass it on the auxiliary contacts of 95 and 96 for the overload. And then to the push button off, and then to the push button on left, then to the closed contacts of the first contactor 21 and 22. And then return to the coil of the second contactor, then to the neutral. Let's take another point after the push button off and return into the right push button on, and then to the closed contact points of the second contactor. And then back to the first contactor coil and then to the neutral line. The idea is that I connect the push button on instead of directly connected to the contactor by passing them first on the closed contact points of the opposite contactor, and then returning them to the main coil of the contactor itself, and so on. Let's see what is the reason. If the circuit is turned on, let's see what happens. We lift the main breaker button up so that it's always on. Press the green start button for the motor's rotation to the right. When pressure is applied, the internal contact points will change from open to the closed, thus completing the circuit path, and electric current will pass to the electric circuit elements. Now it will run from the beginning of the phase to the circuit breaker, as you can see, to the closed contacts in the circuit, then to the stopwatch, and then to the right push button. Why doesn't the current go on the left push button? Because it's originally in an open state, meaning the circuit is opened. The current will pass through the closed contact points of the second contactor and then back to the coil of the first contactor. So the coil is magnetized and works to attract the movement of the contactor to the inside, which led to a change in the position of the contact points from open to closed and vice versa. The main contacts of the power were closed and the auxiliary contacts of the contactor were opened. As soon as the main poles started to enter three-phase electricity from the electrical network, which led it to being fed with the voltage, which led to the motor's rotation to the right in the normal way. Why did I connect the feed of the second contactor coil to the closed points of the first contactor? Why is it important? Assuming someone came and pressed the left push button on, an electric current will pass and will find in this part an open circuit. But if it was closed, the electric current would enter through it and then to the first contactor coil and magnetize, which works to close the power circuit of the motor, and thus an electric shock occurs between the phases, which leads to an electric shock, the composition of the elements inside the electrical panel. This is done to increase safety and to prevent other electricity from entering the contactor, so that the contactors don't work together. So one must turn on and the second be turned off. The phases will contact and cause a large short circuit and the circuit elements will burn out. I hope I made this idea very clear to you, as if I moved my finger to press the left push button on, what is happening? Nothing will happen because the circuit path is open through the auxiliary points of the second contactor, so no electric current passes. If we want to stop the motor, we go to the stop button or push button on. If we want to stop the motor, we go to the stop button. From the push button off, I cut the circuit, meaning that the electric current stopped passing to the entire circuit, including the contactors, and return to their normal open state. If we want to operate the motor in a left reverse motion, we press the left push button on and the electric current will flow in the same way to pass through the second contactor coil and make it magnetize and connect the power circuit to rotate the motor on a reverse movement according to the inverted phases after this contactor. As you see here again, look again please. K2 contactor works now, but K1 contactor is off. So when this contactor works, this motor will work also. This is how our dear friends will be. So we show you on the realistic and practical picture the mechanism of operation of a three-phase motor, either by rotation right or left. And this is used, of course, in very important applications in machines, in factories, and commercial establishments. We wish you more success and benefit, and thank you for your listening.